on the doodle. Before we start, I just wanted to get a sense check of how familiar we are here with Python. Is it mostly yes or mostly no? Because the pace of the rest of the thing will depend on that.
No.
Mostly no. Okay, nothing to worry. And you guys are familiar with things like GitHub and Git. Okay, that's not even a problem. So I do not have a PPT PowerPoint. So what you'll do is that if you have your laptop open and it's connected, you can go to Google and search for Quant GitHub. And you'll find a repo called Demo Strategies, Blue Shift Demo Strategies. If you're familiar with GitHub, this is a good time to actually take a clone of this strategy. Otherwise, we can simply go into this folder inside that demo strategy called PyData. And we begin. So before we begin with the hands-on session, I'd like to cover a few points about some background, some very basic background stuff, and also some amount of idea about what is quantitative strategies. And so most of us have heard of this name, I suppose, and many of us do use technical indicators or want to use machine learning or those kind of stuff. But if we do not understand the basic principles of quantitative strategies, then these things are probably not going to help in a consistent way, right? So some basic definitions we start with. We have four things: systematic trading, quantitative trading, algorithmic trading, and high frequency trading. So are we familiar with all this, the differences between all these things? Because in most of the popular media, people usually get very confused with all these terms and use them interchangeably. Systematic trading means that your trading decisions are made systematically. Even if you are calling up your broker to place the trade, it can be systematic trading. It's got nothing to do with computers even. If you systematically, for example, if you wake up on the left side of your bed, you sell, and right side you buy, that's systematic trading, okay? So the trading decision making is systematic. Quantitative trading means the systematic, a subset of systematic trading, where your decisions are based on quantitative techniques. So the first one is excluded. Waking up right or left side of your bed is no longer a quantitative trading, right? So we use typically some sort of statistical techniques or some other another popular segment of techniques that are popular in quantitative trading is digital signal processing. So those kind of things we use on quantitative trading. The algorithmic trading, again, it has got nothing to do with how you decide what to trade. Algorithmic trading is when you execute your trade through computers. Now, the reason you want to do it is because you want to do it typically in a much faster pace than a human. So obviously your trading decisions will also be probably driven by computer. But that is not the whole point. The whole point is that your execution is through computers. And high frequency is a subdomain, a subset of algorithmic trading, where your volumes are really, really high. And because of that, even the kind of strategies they use are entirely different. So these are the basic the definitions. So the dimensions are how you decide, and what kind of techniques you use, and how you execute. So now we come back to Blue Shift. So of this, all the things that you have seen here, the systematic, quantitative, and algorithmic. The blue shift focuses on systematic trading in general, and definitely not on the high frequency side, because blue shift is a tool that is web based, and you cannot do high frequency trading through a browser. You have to have very dedicated hardware, and if most of you are looking for high frequency trading as running your own capital, probably that's not a very good approach, because it takes a huge amount of investment in hardwares, and also a huge amount of investment in co-locating your hardwares. And it's kind of an institutional trading. So it is not for retail. So let's put that aside. Apart from that, whatever is left, it can be done. And Blueshift is a platform to help people do that. What do we provide? We provide free data. Right now we have minute level data for FX, for equities and futures in Indian market and US markets. And we also have, for Indian markets, we have around 3 years of data for minute level. For US market, we have more than 10 years of data. It doesn't mean that we love the US market more. It just means that we are not very confident with the past data that we got for Indian markets. Because doing backtest and developing a strategy is good, but if you do it with bad data, you might as well not do it. It can be very dangerous, right? Now, we'll be talking about trading strategies. So before we do that, just a bit of background, what is a trading strategy? So strategy is usually, this term comes from, I'm sure many of you know about it, from a discipline in economics and mathematics called game theory. And that says that a strategy is a rule that allow you to respond in any state of the given game. So a trading strategy is basically a set of rules that allow you to respond in any state of the game that is trading or investing. Now, in a typical game, for example, a chess or a poker, is quite different than the markets. There are two differences. The first difference is between, say, poker and chess. The chess is a kind of a open hand game where you exactly know what the opposition states are. You can see the pieces, the chess pieces. The poker is a bit more difficult because you do not know what the opposition's hands are, right? But they are still better than markets in the sense that at least the rules are known and everybody sticks to the rule, otherwise the house will kick them out. In markets, the rules are ever changing. So, and of course, you do not know what the opponent's hands are. So it's a much more complex game, and it's a massively multiplayer game. So we call this Mr. Market. And to put some structure into the entire state of things, so we talk about some economic theories like asset pricing and like efficient market hypothesis and all this. I believe the first session has been on the asset pricing quite a bit, right? So we have some idea about how assets are priced. So we'll not get into that. So this is a very brief overview of what strategy is. And irrespective of your trading style, whatever you trade or invest in the market can be captured in this picture. So on the y-axis, we have different styles of trading. So someone can be a quantitative trader, or someone can be fundamental trading, also known as buffer style investing, value investing. And on the x-axis, we have the different drivers of the P&Ls, profits and losses, right? So many people do across different ways of trading the same thing, but in a very different way. How? For example, a mean reversion profit is done by the typical value trader by buying cheap stocks, like Buffett do, right? On the other hand, a quantitative trader will call this not value investing, will call this a statistical arbitrage. So the essence is very same. You are trying to buy something which is lower than its fair value, either absolute terms. For example, in value investing, we talk about absolute terms. This company, its book value to price is this much. So I think in absolute terms, it's very cheap. I want to buy. In quantitative technique, it is called statistical arbitrage. It's no longer in absolute term. We talk in terms of relative price. We think that the Nifty futures is the first features is cheaper than systematically what we have seen for history compared to the second future. So on relative basis, it is cheaper. So we think that it will revert to the mean, and that's why we buy. So this is another way of doing the same kind of strategy. So everything is more or less can be captured on this. So for example, the trading strategy is called in quant domain is called momentum investing. We'll actually see quite a lot of it. And in fundamental investing, that is called factor investing, not in a quantitative manner, but in a fundamental manner. So of all this, which are the things that it can be that can be made systematic? Any guess? Of all the different types of all the boxes that you see here. Which can be systematic. That is, you can decide the rules and generate the buy and sell signals systematically. Yes? Yes? Definitely? All of them. Actually, that's the answer, except the last cell in the fundamental, which is written usually discretionary. So apart from that thing, where it is discretionary and event-based trading in a fundamental manner, everything else can be made systematically. And a blue shift to the platform to help you do that. Now, we do not support all of it right now. Because of two reasons. One is we do not have all the data that we require for it. For example, we yet do not have the fundamental data on the blue shift. You only have price data. Fundamental data is on its way. And secondly, we do not have all the tools that are required for it. And again, it is because they are on the way. So once we have both the fundamental and the other types of data and the tools, you can trade pretty much everything here on your shift systematically. Another thing is why you are here. While we are discussing about, it's like an overdrive of a rock concert. Why we are here? Why we want to do quantitative trading? What's wrong with discretionary trading? What's wrong with manual trading? Any feedback? What is wrong with manual trading? Emotions as well. Factual information. Okay. Anyone else? Sorry? Time consuming, definitely. Patience. Means lack of patience or more of it? Both. Okay. That's interesting. Sorry? Biases. Yes, behavioral biases. Yeah. Sorry? Not to become redundant. So, okay. That is trading with other people's money that we're talking about. Okay. Anyone else? No consistency. And? Sorry? Fat finger, yeah. Okay, so let me tell you, all of these are very, very good reasons to do systematic trading or trading using a computer. But when computers fail, they fail spectacularly. So, for example, we have some wonderful examples of fat finger errors from computers, right? I think one of the example I can think of is in the FX trading for Credit Suisse, and they forgot to stop the refresh rate of the trading screen, and it was refreshing at a very fast rate. And when you were supposed to send only one trade, thousands of trades were sent. So that is kind of a fat finger for computer. So computer bugs are always inevitable. biases, for example. So if you take some data and if you do a back test, you will find that it doesn't work. So what you'll do is that you will tweak the parameters. And then after you torture it enough, it will confess to a fantastic strategy. And you will take that strategy and it will fail. So you can build in biases inside of computer-based strategies as well. So a computer strategy is as good as the human who developed it, right? So one of the most important reason is that, as this gentleman mentioned, that we do not have enough time, and and also the emotion that this gentleman mentioned. Emotion is, of course, it helps, but you cannot totally handle it. For example, you are running a strategy based on computer, and ultimately you are the person who can kill it. So if you are emotional, you can still hit the kill switch, right? So you cannot totally get away with it. Uh, One of the biggest reason that we should talk about quantitative strategies is the amount of time we require to analyze a given number of stocks. Why it is important? Um, let's take an example. So we have two asset managers, if you can see here, the question. So one is a discretionary manager who follow 10 stocks diligently, right? And then another is a systematic manager who follow 500 stocks. Why the systematic manager can follow 500? Because he's using a computer to follow all of them, right? So it is done automatically. Now, if you ask these two questions, so what is the hit ratio for the A? Hit ratio means your investing acumen. Means if you pick in stocks, what is the percentage of that will be a success? Where the percentage of that will make money. So if you're, what should be the hit ratio of A? If you want to perform, if you want to have outperformance in at least 50% of the stocks that it handles, that is in 5 stocks. And what should be the same number for the systematic manager? So what we are basically asking is that what should be the skill level of A versus B for the same performance metrics? And you will be amazed that the B requires a much, much lower skill level if you see the graph. So a probability of success at a 95% confidence level, A requires a hit ratio of over 70%. That means he has to be right 7 out of 10 times. Whereas B requires slightly over 50%, around 55 to 60%. And that's a huge, huge gain. And why the gain? Is simply because of maths. It's nothing but he's looking at more number of stocks. And if you guys are familiar with basic statistics, so for example, I used binomial distribution to compute this graphs. So you can do the same. You can go back and try your hand to see whether it's lying or not. So you see that the requirement is the asking rate is much lower. And that is one of the biggest reasons that we should do quantitative trading. And if you are doing quantitative trading, just using Nifty and trying to fit a indicator, a technical indicator, and trying to predict whether it will go up and go down, that's really not quantitative trading. Because the gist of the quantitative trading is that you are looking at many number of things and you're picking up the best. For example, you are using the same indicator over 500 stocks in the Nifty 50, and you have a threshold where you want to enter. And any stocks that reach that threshold, you go and trade that. That is quantitative trading. Because here you are leveraging the large number that is in your favor. Right? So in every discipline has a fundamental law, right? Thermodynamics, your mechanics, everything. So investment also has a fundamental law. Anyone is familiar with this law? What is your background, sorry? Okay, is it covered with CFA? Okay, is it written right? Can I explain? Yes. So IR is the information ratio. So for the rest of us who doesn't know it, so IR means information ratio. That is over performance over your chosen benchmark. So your portfolio minus, so for example, if your benchmark is Nifty, you take the difference in return divided by the volatility of portfolio. That is information ratio. And information coefficient is the one that you just discussed, the hit ratio, you can say, right? How many times you get your trades correct, and that N, that is the most advantageous thing for quantitative trading. That is the number of independent bets you're making, right? And TC is something called transfer coefficient. That is not very important. It basically says that whether if you think something, can you express that accurately in your trading? That is where the emotion comes in. So this is the fundamental law. The discretionary trading and quantitative trading are not adversarial with respect to each other. You can do both. The advantage in quantitative trading is this N. You can have many independent bets because you can look at many different instruments, stocks or futures or anything. Whereas in discretionary, your edge comes from your deep insight about a particular company. So typically the outcome is that in quantitative trading, your returns are steady and your returns are predictable. You don't make a huge amount of gains, so you don't make what they call it a multi-bagger. So usually you don't make multi-bagger in quantitative trading, but you almost surely make money, right? Whereas in discretionary trading, depending on your skill, you can make a huge amount of money, but most of the time you will not make money. So they are complementary to each other, and in an ideal portfolio, you should have both. But the basic advantage that you want to, the takeaway you want to have from this discussion is that N is our friend, and that is our basic advantage. If you are developing a quantitative strategy, if you are not thinking about this aspect, you are probably not doing it in the right approach. So now that you know about quantitative trading, by the way, all this materials is in a GitHub, and it is free to download and free to flow. So now that you know about what systematic trading is, how we go about developing it. So this is the basic cycle that we have in systematic trading. We start with defining our universe. What is our universe? Is the number of stocks we are going to monitor, number of stocks or instruments or whatever we are going to trade. Anything beyond, we are not going to touch. It is a very, very hard requirement that you define it at the onset. Otherwise, it's going to play with your strategy. Once you have done it, it can be done in many ways. For example, if you're sitting in India, you cannot, of course, trade the Chinese A shares. So it is outside your universe anyway. So it defines based on your liquidity as well. So if you are retail investors, probably you'll not, the long-dated government bonds probably will not be your universe, right? So you define based on your different requirements like regulations and requirements and your geographical locations. Once you do that, the second thing is to develop a signal generation function. So these are very abstract way of doing it, but we'll get to see how we use it in a concrete manner later on. The second one is generating the signal. Now, generating the signal can be in two ways. One is that you use a function such that all the signals can be generated independently for all the universe, all the stocks in your universe, or it can be that all the signals are dependent. Whichever, you have to have a signal generator. Next thing is that based on the signal, you have to decide what is your target portfolio. What is the difference between signal and target portfolio? That means that you have to apply a sizing function. Sorry? Yeah, so you have to apply a sizing function that takes in your signal and produce a required output, that is the amount of stocks you have to buy or sell. It can also take into account things like how much cash you are left with your account, or what is your current accumulated risk or leverage, or many other things, right? So those things goes into that. Then comes, once you have decided your target portfolio, you have a current portfolio. Now you have to rebalance. Rebalance means whatever you have and whatever you want to be, trade the delta, right? Here you try to optimize your execution. So all your execution related codes goes into this side. So how better you can execute, whether you want to slice or dice your trades, if you do a large volume of trades. So all those execution strategy goes into this part. And then of course you do you complete the circle and try to constantly improve upon it, right? So we'll see a concrete example of this later on. So these are the things that are required for any systematic strategies. We need some inputs. Inputs can be price inputs. It can be fundamental data. It can be macroeconomical input. It can be even what we call Alt-D these days, alternative data, like your Twitter feeds or your Google satellite images. In fact, there are hedge funds who take snapshots of parking lot for the big supermarkets to see that how many customers are they're serving to. So all these kind of things. So you have to first define your inputs. Next comes your rules and logic. So rules and logic is the one that generates the signal. So here you can have two options. One is you have experience about the market. So you form a hypothesis. Those of you who are familiar with statistical hypothesis testing, they can directly connect to it. So you form a hypothesis that if I do this, this should give me good results. So once you form that hypothesis, you need to test it. If you can validate the hypothesis, you accept it, otherwise you reject it. Whichever way, you have to test it. The other way is what we have now, machine learning and artificial intelligence, is we don't know anything about financial market, so we look at the data and ask the data to give us rules. So this is a new way of forming trading strategies which were never heard before. Before this, all this AI/ML came. But this is also a viable option these days. You ask the data to tell you the strategy. Once you have this, the next thing is the backtesting, which we'll be talking about a lot. And for backtesting, many of us do backtesting, right? So how many people here have done some sort of backtesting their strategies? You have done, and there are quite a few, quite a few there. So how we do it? So typically, I don't know, when I first tested my strategy, I just wrote it on an Excel and wrote a formula down, drag it. And so this type of backtesting is, the technical term is called vectorized backtesting. That means we are taking the entire data in the history and doing a single pass and computing our profit and loss. Now, depending on your strategy, this can be okay or this can be deadly. More safe backtesting is what is called event-driven backtesting. That means you are always presenting to your strategy the data only till that day, which is available, which is that day it is trading. So, for example, your strategy is trading, say, for 2nd January of this year till date. So, on the 3rd January, it will only have data from your beginning of your data period till 2nd January. It will not have any data ahead. So that helps us in a very crucial thing which is called look ahead bias. And you won't believe it that how many times you get to see the look ahead bias in your strategy. If you have ever developed a backtest or you're doing in future, if it gives you a fantastic result, always look for this error. Because a fantastic backtest is very, very rare. So if you have one, probably it's got a bug. Okay? So that's why the platform that you need for a proper backtest has to be an event-driven platform. So Blueshift is one. And at the same time, doing backtest is not good enough because Backtest doesn't bring out many other things about your strategy. So before you take it live in any serious way, you have to do a paper trading. Paper trading can be a pure paper trading if your broker provides such a way, or it can be running on a very small capital just for the testing. But this is a very crucial tip. This is what most of us miss, even those of us who do a backtest. And finally, after we thought about our data, our signal generation, rules and logic, validating them with backtest and live threads, the final thing is creating a portfolio. Because, as I said, the rules in the market is ever changing. So no matter how good your strategy is today, it's not going to be the same tomorrow. So we need to have a proper meta strategy that can do an allocation between number of strategies dynamically. We'll not talk about much this because there is a very complex subject in itself, so we'll skip this. So before we go into Blue Shift, we'll do a very basic about Python probably so that everyone can catch up on the speed, and then we'll start. So if you are, so what you can do is that we are not going to use any sort of ID or any sort of editor. We are going to code directly on the browser. So we go to this URL. It's Quant Blue Shift at quantinstitute.com. The reason it's difficult to do anything on any sort of editor here is that any sort of backtest requires data, and data is not very freely available, especially good quality of data. So this platform already have this built in, so that's why we are going to go directly there. So probably we'll end up in a page like this. And you can, if you have already created a user ID, you can directly log in. If you have any Quant-inst user ID, you can log in, or you can create one. In case you do not have it, you can register and create one. It will actually, I should have asked for this before the thing. This is something that I missed. This registration beforehand would have been a very helpful thing. Let me know that if I can go ahead from this point. Yeah. So the process is that you want to sign up, then you provide your details, and then you get a mail back for confirmation. Once you do that confirmation, you're done. So let me know when we can go ahead from here. Cool. Or if you do not want to sign up, you can just avoid giving your details, and we'll go through line by line anyway. It's not that you have to sign up. That's also an option. Yes, so we are going to create new strategies, so it's fine. So can I go ahead? Okay, great. So the first thing we need to do is that we'll need to isolate the things that we're going to do today in a single folder. So this is your workspace, all the things that you see. There are a lot more things on my page, of course, because I have done a lot more things. You will see probably some 4 folders and maybe 1 strategy outside. What you can do is that hit on click folder, create a folder called PyData. and hit create folder. And I have actually already done that. So I have one already there. Right? You can name it whatever you want. PyData is just a suggestion. Okay, so now if I go inside that, here I can create, here we'll create all the strategies that you want to do. So a bit about the Blue Shift itself is that once you go into once you sign up for the platform, you get to see your workspace. Workspace is where you have your strategies and your folders. And the good thing to do if you have signed up for the first time, it is done automatically, by the way, is to take a tour to familiarize yourself about the platform, what happens where. So it's basically giving you a guided tour. This is a button we create. We hit to create strategies, and once you do that, this is where you land up. This area is the area where we'll code. This area is the area where we'll put on the parameters for our backtest to run. And this is an optional place where you can give in some description of the strategy that you have done for our future references. This is where we run a backtest. And in case we need help, of course, help is just a click away. So we are done. So what we'll do is that we'll go into PyData and we'll create a strategy without coding a single thing. We'll say create strategies. We'll type in a name. And then we can select a template. So we provide some templates of the strategies so that you do not have to start from the scratch. We'll not even look at what is at the template. We'll look at after we run the strategy itself. I selected buy and hold NSE. That is the first one in the template option. You can give any name and select the first one. I believe most of us are interested in NSE based strategies here. The others are FX and NYSE. That is not very relevant today. Buy and hold is something that you call a strategy where you mostly buy and never trade. Buy once and hold it throughout the end of the strategy. So it's not a very great or exciting strategy, but sometimes it makes a huge amount of money compared to very exciting strategies. So it's not a bad one to start with. So it has already some code. Let's not get into what the code is there. Let's run the strategy first. We select a data set, which is NSE daily data. Select a start date. For example, I'll select, say, from 2010 1st January. 2010 1st January. That is a start. And end date is the last close, as on Friday. I'll jack up the capital by one more zero. So instead of 10,000, I'll have it 1 lakh. And I'll hit run. So while it is running, it will give you the data as it computes. But while it is doing that, let's have a look at what the strategy is actually doing, right? So those of you who are not familiar with Python, it's a very, very easy language to pick up. It's a very easy language to start. It's an entirely different thing. It's a very difficult language to master, but it's a very easy language to start, okay? So the first statement says that from zipline.api, import a bunch of stuff. The one that is highlighted. So zipline is the core library that you are using. Of course, it's going to be replaced by an in-house library very soon, but on the backtest, it will stay there for a while. I think your screen is very similar to what you see here, except this button. None of you have this button, right? So this is an experimental feature that we are having since I have privileged access. That's why the button shows for me. We are going live where you can trade directly from writing a strategy and then go live and take your strategy live. But it is still quite a early beginning of the experiment, so it will take some time, especially for Indian market. But there's just an idea about the features to come. So the first part, we are importing some. So we are launching for FX market this month, but for equity markets, probably it will be sometime towards November or maybe October. So we are importing some functions from Zipline, and then we are defining a function. In Python, the function is defined like this. So we are defining a function with a keyword called def, and then we are defining a bunch of stocks here. So if you remember, just we discussed, we have first have to specify our universe. So this is our universe. So this is the universe of stocks we are going to trade. And how you are going to trade? We have another function here that is called a function named schedule function. So schedule function is, if you see that it is pretty simple to figure out what it is doing. Is calling this function rebalance at the start of the month, means even without knowing anything about it, you can pretty much say that what it is doing. At the start of the month, it is calling that function, and it's calling when the market opens and after 2.5 hours from the market, right? So these are just API functions. So this is nothing to actually commit to the memory. So you can just go to Google and search on this, and you'll get all this, how to do this. What is important is to know that what is possible. And once you know that, you can always Google and find out how to do that specifically. So what you're doing is that we're scheduling a function to be called every month at the start of the month from the 2.5 hours from the market open. And that function is called rebalance. And that function is defined down below. Sorry?
When we're taking data 2.5 hours.
Oh, you can do at the market open also, but typically the market opens is not a very stable period. So you want to do some run-in of the market prices where the price discovery has stabilized, right? And that function is again a very simple function. It's doing a for loop. For loop is a uh, for loop is a construct in any programming language to do the same thing over many number of elements, right? So here we are doing the same thing over all the elements in our universe, all the stocks in your universe. And what is that same thing we are doing? We are using a function called order target percent, 0.1. 0.1 means 10%. That means we want 10% of our portfolio value to be invested in that stock for all the universe of stocks, right? So there are 9 stocks, I believe. 9, right? So that means we'll be still left with 10% in cash, right? So it's a very simple programming. If you know about what is possible, it is very easy to find out on Google. So Zipline has a good documentation, and you can Google almost anything on that. You can go to directly their documentation itself. And this is how we do a very simple buy and hold strategies. If you run a backtest, so this is what you ran, which is called a quick backtest. It does a quick computation, event-driven manner, so that there is no forward-looking bias. But at the same time, it computes only a few things, not a lot of things. What you can do is that we can run a more detailed test where we'll get much more important statistics. And that is what we get here in the new backtest button. We have to specify the data set again. We have to specify a start date. I'll pick a later start date just to make it run faster. So for example, from 2013. But in this case, it will run in the background. So you will get a notification on the top that says that the status of your backtest has been processed, and you are free to actually continue working on whatever you're doing here. Once the backtest is done, you will again get a notification. In case you are impatient, you can go directly here as well. And once the backtest is complete, you'll see this. Now here I see much more details. So we have many different parameters that you see here. We'll talk about all these parameters. Also, you can go to tier sheet. Tier sheet gives you more details about this particular strategy. So for example, we are plotting the gross leverage and we see that it started from 0, went up to 0.9 and more or less stayed there. The reason is that we are ordering only 90% of our cash. So 0.9 is the leverage. Similarly, so you have to go to the tier sheet tab. Similarly, you can also get to see the histogram of your returns. So sometimes just the headline number doesn't give you a good enough idea. You need to see the distribution. So if you have a very high average value but a very bad left tab, that means probably you are not going to run this strategy. There's a negative skew there, right? How did I reach here? So if you are on this strategy page and if you have run a backtest, you have to run a backtest first, right? Fill in the details, and then you can go to the backtest page itself directly from the breadcrumbs, or you can go it from the notifications also. Whichever way, we'll end up here. And if you have any backtest, it will be listed here. And if it is completed, you will have this button to click, and you go back to this page. Is everyone with me? Is the pace is okay, or is it too slow or too fast? Sorry, a bit fast. Because we are only 6:30. so that is a problem. So the idea is not to basically learn everything today itself. It's to get the exposure that what is possible, and you can always go back and do it at your own leisure. And we are always there to actually help you. We have a mail support called blueshift-support@quantinstitute.com. You can send all your queries there. We also have a community. You can put a post there and tag it with Blueshift. Will be very fast to reply, faster than the mail. So once you go to the tier sheet, you see all this. You see the drawdowns as well. So for example, this is the drawdowns. You see the performance across the months. So this is called typical hit charts. So you see that for various years and months, what has been the performance levels. And if you're a serious trader, the most important thing here is, right? So it's just years on the below and the months on the top. So each box refers to a particular month of a particular year. And if it is green, that means you made good money. If it is deep red, you lost money. So at a glance, it gives you the kind of profile your strategy had in the backtest. Why it is important is that if your overall return is very high, but most of the months you lost money, since you do not have infinite capital, you probably cannot run that strategy because you never know when you are going to get stopped out, right? So you want a strategy that is, even if it's a smaller average return, it must be green almost all the time. That will allow you to stay in the market. Otherwise, you'll be kicked out of the market, and you will miss a big gain that the strategy may have in future, right? And if you're a serious trader, so this is a very important tab for you. That gives you the list of transactions that this strategy has done. all those transactions with exact date and time. So here we are. We haven't done a single coding, and we have run a quite a decent backtesting, and we have seen what is possible. Now, for those of you who are not familiar with Python, I'm going to delete this strategy and give you some 10 minutes crash course in Python. Okay, the kind of Python we need to know to do this. So we don't need to be an expert in Python to run it. We need to have some basic idea. What you need to be an expert, hopefully, is in financials and quantitative trading itself. You don't need to be expert in Python because that part is taken care by the platform. So you need to. So the better you are in your financial acumen, the better models you'll build. But what we are trying to do here using this platform is to take care of the grunt of doing all those coding and running the infrastructure and curating the data, collecting the data. So all those nitty-gritty things that really doesn't add value to your strategy, that you are taking care of it. And the core thing that you need to invest here is your ideas, right? So the basic strategies we need here is basic Python we need here is that first we need to know how to import stuff. Import means some functions or some other things defined in elsewhere in some other Python file. I want to use it. In different languages, this is done differently. If you are familiar with C++, this is called hash include. If you're familiar with R, this is called sometimes source or sometimes called require, sometimes called library. For loading a library in Python, this is called import, right? So import zipline.api means I import everything that is defined in zipline.api. If I say from zipline.api import symbol, that means I import only symbol function from zipline.api. And if I say that from zipline.api import symbol as sim, that means I have imported symbol only, but I am not using the particular name as symbol. I'm just using the name sim to refer to the same thing, right? So this is the first thing, so that we get the other libraries that are already defined there into our code without writing them themselves, right? And then the next thing we need to know is to how to define a function. So again, many language does this many different way. The function, the concept of function is related some piece of code that has some particular logic of execution. So when your program runs, the functions are run in a particular logic. If you are familiar with computer science, you already know what I mean by particular logic. It's get pushed to something called stack, and then once it is run, then it's got popped out. Basically, the programming language ensures that it's got a consistent environment. So let's stop at that and let's see that how we do this function thing. So if I want to define any function, we say def in Python, and if is the name of the function. If it takes any parameters or arguments, then we put a argument list within a parenthesis, and then we define our code. For example, if I do this, we have just defined a function called f that takes in an argument x and prints 42. You may wonder that why I've taken the argument x, so let's print that. So this is a very basic thing in Python. It's a very basic way of defining a function. There are other complicated way of doing things, but let's not get into that, right? And then there is a concept of variable. So you are already familiar with the variables if you have looked at it. So for example, here x is a variable which has been passed on as a formal argument of the function. Otherwise, you can also define other variables. So for example, I can say y is equal to 12 and then print y. So this function will first print the x, the argument that was passed. Then it has a new variable called y, which has been assigned the value of 12, and then print it. So variable is basically a placeholder for different types of values. So different types of values can be a number like 12, can be a character. In Python they're called string, like this, and so on. So if you know variables, and if you know functions, and if you know how to import stuff, you are good to go with BlueShift. Okay, so this is our slightly less than 10 minutes crash course on Python. Those of you know Python, please pardon me. So what happens in BlueShift? So we have seen all this code that you have developed, right? So this is what you do. So BlueShift is quite a complex program. What you do is that we take your program, we do some we do something on this. We basically compile and do some checks and then execute, and then we take out different things that you want from your code. We'll see that what are those different important things. And once we have this, then I have pretty clear idea about what you wanted to do with your code. And then we run a big while loop. While loop means we run infinitely. We try to do the same thing. So for example, for each day we are doing a same thing in a backtest. So that's a big while loop. And in that big while loop, we call it an event loop. We take your function, we execute your function the way you want it to, and then collect the results, and then provide you back the results. So this is pretty much what you do. I'm sure it raises more questions than answer them, but in case you have any questions, let me know after the session. So there are two kind of API functions that we have here. API is the application program interface. So as I said that if you can import and if you can write functions, you can use BlueShift. So you have to import the API functions, and then you have to write your own functions using those API functions to run your strategy. So typically, if you forget about BlueShift or you forget about Python or forget about coding anything, so the typical way our trader spend the day is that he wakes up in the morning before the market. He does something to get prepared for the market. For example, read the newspaper, does some P&L calculation from the last night. And then when the market is open, then he's ready. So every time he sees a new price, he's ready to react to it, right? And once that day is over, throughout the market, whatever he has done, good or bad, at the end, again, he has some things to do. So he has to compute his current positions. He has to check whether the broker reports the same positions or not, which is called reconciliation. Then he has to compute the P&L. Then if there's a margin call, he has to post them. Then probably you can go to sleep or other more important things. So this is the same philosophy that happens in BlueShift as well. So we have this API functions, the entry point functions here. The first function is called initialize. This function is whatever you write in this function will be executed when your strategy starts for the very first time, only once. After that, for each day, the before trading start will run. And then for each new pricing that arrives, in our case, every minute, your handle data function gets called. In this version, we do not have any API function for after market hours. In the next version, we'll have. And then all your trading has been done. Then at the very end of your backtest, we call a function called analyze. So whatever analysis you want to do, your code goes there, right? So let's take an example and see how it works. I think I have a ready-made example here. By the way, if you are wondering where the codes are, actually, they are also in the same this same GitHub place. You can just create a new window and go to this files and see that. So for example, the code we are looking right now is this one. You can copy and paste directly. You don't have to remember what the code is. You just have to understand what the code is trying to achieve. So as I say, the first thing is to import the APIs. So we are using Zipline API from Zipline API import. Yeah. Sorry. You have to go to the GitHub. Our Quant Instinct GitHub page. Our Quant Instinct GitHub page. So if you go there, you will see that there is something called Blue Shift Demo Strategies. Under that, there will be a folder called PyData. You got it? Cool. So everything I'm talking about is already there, publicly available. There's no need to basically copy it or do as I do. You can just sit back and relax if you want, or you can run it as well if you want to. So you have to pick up this strategy flow. So you can just copy paste into Blue Shift this strategy. So what we are trying to do here is that we are trying to see that the way the platform works. So we are importing some functions here. So yeah. So if you copy, Control C, you can create a new strategy, delete whatever the code is there, go to the first line, paste. If you are using a MacBook, probably you have to do Command C, and otherwise it's a Control C. So it's a pretty standard thing. And the first thing we're doing is we're importing. You give a new name, any name, and select any template, because we are going to delete that template entirely. And we are replacing this new strategy code, right? So what we're trying to do here is that we just imported some API functions. The first function is get date time. This gives you the current date time at any point during the backtest run. Next, we have a function called schedule function. This is already we have seen that schedules a particular function to be called at a particular frequency. Then we have date rules and time rules that defines the frequency of the schedule function. So these are the only things that we're doing. The first API entry point function is called initialize. This is the function we said that is called only first time. So what we are doing here is that we are using a print statement using get date time to see that when it was called. Right? Pretty simple. Print is the standard print function, which is the Python version of writing to the system output. Next, in the same initialize function, we are writing a schedule function call to schedule a particular function called rebalance. Why you want to do this? We want to see that when this rebalance function is being called, right? So we have done a date rule of month start and time rule of market open. So we want to see that it is at the first of the month at 9:15 when the market opens, it is getting called, right? That's what it should give. You can forget this. This is basically to reduce the number of prints that we'll have. Then we have this rebalance function, which is copy pasting the same thing. We want to see when it was called. Then the before trading start, again we are doing the same thing. We want to see when it was called. And handle data. You can forget about this particular first line. We are basically using this function to reduce the number of prints. So you are printing at every 2 hours instead of every minute. This function will be called every minute. We are printing only every 2 hours. Otherwise, there will be too many prints to see. And we are again printing when it was called. So if you run it, to see the exact timing of calls, we are going to run it on a minute database. So we are computing the NSA minute data. And to run it fast, we are going to run it for a very short period of time. So for example, if I pick only, say, okay, just for a week. So essentially, as you see that it is just printing. It is not doing any trades. But Zipline doesn't care about, or Blue Sheep doesn't care about whether you're trading or not. So as a result, your portfolio is flat because you started with 100,000, 10,000, and didn't do any trade, so that doesn't change. But this is not we are doing for trading. We're doing for seeing what is happening to the functions, and this is where they are. So if you see, it's printing the times. So we ran from 1st February to, I think, 8th February. So on the 1st February, the initialize is getting called at midnight. So just when the date starts at midnight, we call initialize. The before trading start is getting called at on the same day at 8:45. That is the time trigger that you have set. So the market opens at 9:15. So at half an hour before that, you have set the trigger. So at 8:45, the before trading start is triggered. Then the rebalance is getting triggered. The rebalance was month start and at the market opens. So at month start is 1st February, yes. Market opens 9:15, yes. So it gets triggered. And then from then onwards, it's only handle data every 2 hours because we have set the frequency for that. So at 10 o'clock, 12 o'clock, and 2 o'clock. And then, of course, it goes to the next day. So similarly, the same thing goes on happening. So before trading start, rebalance is called only on the first day. For the next day, the rebalance is not there. It's only handle data and before trading start. So I think now you have some idea about how the strategy works. So whatever you define in initialize function, we run it for the first time. Before trading function every day once, start of the day. In handle data, every minute. And in schedule function, whatever the frequency you define. So that's pretty much all you have to schedule your strategy. And whatever you write inside is what we run. Of course, we do some security checks, so you cannot do many bad things. But pretty much whatever you write, we run. So what you have to determine is that where you want to put what. So typically, initialize function is the function where you define your trading universe, right? And then in the before trading starts, you do some model computation if it is required. In handle data is where you actually query for price and compute your signal. And if your trading is relatively faster, it's a minute level strategy, then that is where you trade as well. And in rebalance, in case you are doing a scheduled rebalance, then that is usually used for trading your portfolio, right? Of course, you can use it in any way you want. The only thing that is the constraint is that you can only trade during the handle data period. That is start of the market hours till the end. You cannot trade in before trading start or in initialize because then the market is not open itself, right? So this is how the strategy flow is. Now let's go back. Now let's, before we get into developing a momentum strategy, let's understand what is momentum a bit, right? I believe you guys have a first session on alpha. You have some sort of idea about what is alpha. Now, in layman's, okay, not exactly layman's term, but in a different perspective, I'm sure you've already seen this equation. So your R is your actual realized return of a particular stock. That is some intercept. We call them as alpha. And then some summation of various contribution from various factors. And then some white noise. Now, these factors can be anything. I believe you have looked at many different factors like size and market factor, like you also probably looked at momentum factor. And there are many other factors. In fact, one of the big quant firm called Equia, they have a complete list of factors collected from various academic papers. And I think for equities that run into something like 65 different factors. So there's an endless list of factors. So all these factors, whatever you think are important, they contribute to the market and they add up plus the alpha, the intercept, as the total realized return. Now, of course, the realized return is something that happened in the past. In future, what you get is the expected return. That is our best bet, right? Now, in expected return, if you are very adamant follower of efficient market hypothesis, you will say that there is no alpha because that has been arbitraged away. And if you are a follower of um, modern portfolio theory, then you'll say there is no idiosyncratic risk as well because that can also be diversified away. So you are not going to get any, you're not going to get paid for taking idiosyncratic risk because it has no price. Because it can be diversified away, so you must be a fool to actually have an exposure on that. So no price for taking a foolish risk, right? So all you're left with is your risk-free rate and your factors. Now, your objective is to create a portfolio that outperforms. That's a very simple objective. First try is that you try to capture any alpha and try to define, you try to capture any factor and try to define alpha to your advantage. So for example, if you define alpha as anything above market return, this is one of the earliest definition of alpha from Jensen's, then capturing any factor will give you a positive alpha. So that is, you can just generate extraordinary return not by mathematics, just by definition. Okay? That's not a bad thing to do. Sometimes it's helpful. The next thing is the pure alpha, where all you see here is that risk premium and the beta, they're all constant. That's an ideal scenario to be in. So you identify the factor in contribution doesn't change, the factor itself doesn't vary. So your returns are constant and positive and high, hopefully. So that's pure alpha. But of course, we cannot have pure alpha. That's kind of a holy grail. Um, next best thing that can happen is that um, your risk premium is constant. Maybe your factor contribution is going up and down. So delta F is varying over time, but your beta is constant, right? So that is, you are taking a exposure to a factor. So it's kind of a beta, not the market beta, but factor beta. So since it's giving you a high positive value of beta, so it is kind of a beta strategy. You must have heard of these terms called smart beta and all those these days. So this is a smart beta strategy, and that is something that you can hope for. Now later on, the next best thing is to your beta is not very constant, and your risk premium, your delta F is also not very constant. So in this scenario, what you want to do is that you want to try to focus on how to predict the change in delta F. So this is in general called factor timing. We all do factor timing on the market factor. We try to time the market by using different technical indicators. If you want to try to do the same thing for many other things, not only for market, so this is called factor timing. And finally, if that doesn't work, then probably this market is not for quantitative trading. So not necessarily all market is for quantitative trading. So if someone says that do quantitative trading will make money, it's probably just trying to sell you some snake oil. Okay. So for example, in 2007, there was a huge amount of quant crash. In 2009 also, when the market started to come up after the Lehman bust, right? 2009, it came up from the bottomed out. And that was a very bad time for quant strategies because quant strategy try to persist and try to think that whatever happened in the past will persist. So whenever there's a sharp change, quant strategies doesn't perform very good. So this is, in a nutshell, what alpha is. So in this scenario, momentum is just one of those FIs, right? One of those factors is momentum. What is momentum? Momentum is the idea that whatever happened in the past will continue. Now you will very well will argue this, but it has been a academically proven factor. So it is not something like those 70s technical charts like many different head and shoulders and other things. So it is a solid academically proven factor. So there are usually two types of momentum. One is you have all the assets in your universe, you compute their past returns, you want to pick the winner, and we want to sell the loser, and you want to do it in a cross-sectional way. That means you compute all the returns of all the stocks, then you rank them from top to bottom, and then you buy the top ones, which has the biggest positive return, and not biggest positive, biggest returns, and sell the bottom where they have the lowest returns. Now, this biggest and lowest can be of any sign. For example, if the market is entirely going up, everyone will be positive, but still you sell those positive return stocks because they are at the bottom, right? And you buy the ones that are at the top. Similarly, the market is going down, everything will be negative, but you still buy the negative return stocks because they're at the top, right? So you don't care about whether the market is going down or not. You just take all the returns, you arrange them in the increasing order, you buy the highest ones, you sell the lowest ones. So by design, if you think about it, it is always market neutral, right? So whatever amount you're buying, the same amount you're selling, right? So you ideally you should not have any exposure to the market, right? The second way of doing the same momentum thing, so this is called cross-sectional momentum. The second way of doing a similar momentum factor is what is called time series momentum factor. Here, we do care about whether it is up or down, whether it is positive or negative. What you're doing is that, again, we are computing all the returns on the stocks, but now we are splitting them into two. We're splitting the ones that are positive, we're splitting the ones that are negative. And on the negative, who are the least negatives, who are the most negatives, we're shorting them. And on the positives, who are the most positive, we're buying them. Now, this is not by design market neutral. Why? Because there may be cases where everything is positive. You have then nothing to short, right? So it is not always market neutral. In a high bull market, you will only have things to buy. So it has some inherent market exposure as well, right? So these are the two ways of doing the momentum strategies. So if you go back, now things may get a bit complicated, but stay with me. So how do we do this kind of things? Now, as you see that, what you need to do is that, say we want to do this strategy every month, right? So first we have to do a schedule function to schedule a particular rebalance which does this computation, right? What you need to do in that function, we have to get all the prices of all the stocks that are trading at that point in time, right? So you imagine that if you are writing an Excel formula for doing this, how complicated that can get, right? So all the stocks that are trading on that particular day, you take all of them. Then you compute the returns for all of them. And then you arrange them. And then you pick the things to short and things to buy, right? So this kind of things comes over and over in quantitative strategies. Here we are ranking based on the returns, the past 12-month returns. So it can be anything. We can rank based on, say, for example, the volatility. In fact, there is a factor called low volatility factor. We can actually do it against on anything that we can do it on, say, a technical indicator. We can do it on RSI. We can do it on any other things. We can do on their price to book value ratio. So whatever metric we can think of, we can do the same. Sorry, not audible. Okay, I'll try to. So It can be anything, basically. The metric. For momentum factor, the metric is last 12 months return. For any generic factor, so if you are doing factor investing in general, factor research in general, your total setup remains the same. That we pick all the stocks, you rank them based on some particular metric, and you try to evaluate what is the performance. And what changes is that metric, right? So since this comes over and over and over again, so we built a way to do that. So what we do is that we devise something called pipeline. This is also built in Zipline. And this is essentially, if you guys are familiar with computational graph, this is essentially a computational graph. I think many of you are familiar with TensorFlow. So TensorFlow is essentially also a computation graph. So this is also a computation graph. TensorFlow does some other sort of computation. This does some other sort of computation. So you feed your matrix through that graph, and the graph do not compute till when it is absolutely necessary. So that makes it a very efficient computation. So if you see that, we have a folder called pipelines. So you can get it from here as well. Here is a folder called pipelines. And in pipelines, we have defined some codes. Now this looks very ugly on the first look. So what we'll do is I will just have a look at what it is. We'll skip the drivers and come back here. So essentially, pipeline is a way of computing those, running those computation graphs. So to define a pipeline, what you have to do is that in the initialize, we have to use the API function called attach pipeline. Once you have attached the pipeline to a particular algorithm, then periodically you have to call this pipeline output on that same pipeline. So we'll attach with a name and call this pipeline output function with the same name to get the output, right? And within that pipeline implementation, we have to define the factor that you are trying to compute. So in our case, the factor is past 12-month return. As I say, it can be any metric. So that factor is computed in a particular way so that it can be understood by the computation graph. And that way is that we derive a class. If you are not familiar with class, you can just look at it later on. But if you are familiar with class, what you do is that we derive a class from some base class defined in the API. And there are two types of class there. One is called custom factor, one is called custom filter. The only difference between them is that factor returns a number, filter returns true or false, right? So in that class, there is only one function. That function is called compute. And in that function, automatically, so what you need to compute, to compute the function, you need to know all the things that you are trading and the prices of those things, right? So that function automatically gives you those details. All the assets that are trading on that particular day of computation and the prices of that assets automatically fed by the platform. All you have to do is to, in that compute function, define what you want to compute with those data, right? So if you go and see what is there in the pipeline, so the one that you're going to use is called period return. So in period return, what we are doing is that we have a class derived from the custom factor where you have a compute function where today gives you the day of when it is called, the date time. Assets gives you the assets that are trading on that day, a list of them. And close price gives you the prices of those assets in a matrix. So matrix is on the columns you have the assets and on the rows you have the days. It gives you a matrix. So what we are doing is that we are taking the start price as the first row, end price as the last row, and we are just computing a simple return. End price by start price minus 1. Those of you who are not familiar with Python, you will be amazed that this is automatically done. There is a package called NumPy. If you do this kind of computation, NumPy and pass on a vector instead of a particular scalar, they automatically do the computation for all the vector. It is called broadcasting. So although we are writing it once, but it is being computed for each assets. That is for each column, right? But we are writing it only once. So start price is a vector, one number for each assets. End price is a vector, one number for each assets. Return is a vector, one number for each assets. And we are taking them back to this output called out. And this out will be available with the pipeline output. So the variable that the pipeline output function will refer to will be the same one. So here we have a very efficient way of computing. So you can do this in many ways. So for example, a very generic way of writing this is that in the function itself, you take a generic function and use the apply function of NumPy to apply any function on this price. So it doesn't have to be just the returns of the past 12 months. It can be any function you want to compute, right? So it's a very different, efficient way. Now that you have it, now we go back how the momentum strategy is done. There's some documentation string. You can read it. It's not important. What we are doing here is that we are, from the functions that we have written, our own code, we are importing this. So this is not zipline, this is what we have written. So from PyData, pipeline, pipeline. So you see that there was a PyData. Within this PyData folder, there was a pipelines folder. Within this pipelines folder, pipelines was the name of the code. So the way to import it is to refer the absolute name. PyData, pipelines, pipelines. And you're importing the period return. You're also importing the average volume filter. Let's ignore it for the moment. And then we are doing our usual import stuff for zipline, right? So what is happening in zipline in the initialize? So we are defining our loop back. 12 means 12 months. We are defining also a percentile. We know that we have to buy the top and sell the bottom, but how much? So we define that I'll buy the 5 percentile top and sell the 5 percentile bottom. So that is the parameter here. And we also have a parameter for called min volume, that is to volume filter. If you're doing a quantitative strategy, volume filtering is a very, very important tool, because quantitative strategy depends on trading a lot of assets together. And if your volume is low, that means your liquidity is low. All the things that you're computing on your backtest, all of them will be gone paying for the liquidity price. So please develop all your strategies after some certain serious amount of volume filtering. Otherwise, you're not going to get the real return out of that. Okay, so now that you have done, so we know that you want to run this strategy once a month. So we have done a schedule function. So this is simple, right? It's nothing complicated here. We are scheduling a function every month. And also we want to know that we want to attach the pipeline, just as you see. So we have attached the pipeline and we have named this as strategy pipeline. Now, if you look back and think about the flow of the development of quantitative strategies, we have to generate signal and then call the rebalance. So we have defined, split them, these functionalities into these two functions. So this, before we go and look at the generate signal, we just quickly see that how we are defining the pipelines. So what we are doing is that we are initiating an empty pipeline, an empty graph. In that graph, we are getting this factor function, momentum, and adding it to it. And then we are adding a filter for volume filter as well. Volume filter is also defined in the same file. You can go back and look at what is happening there. So what it does is that it suppresses all the assets that are below a certain amount of volume. Here we have put 1 e to the power 7. That means the traded volume must be, traded turnover must be more than a crore. So now we have defined, we just added that factor computation into our pipeline using this thing called pipeline add. And the computation will be added in this column called momentum. This column also you have supplied. Now, it's not very important to exactly know what we did, but It is important to know why we did it and how we did it. Then later on we can go and Google and figure out what exactly to do it. That's not very important. You can also put us mails to me or us. Sorry? Yes, yes, it's on the repo, on the GitHub repo. It's on the GitHub. Okay, so then what you are doing here. So our generate signal, what it is trying to do is that you're calling this our pipeline output function. And in pipeline output function, once you get the results, it's sorting the value after dropping the non-numbers, which is drop in it. So you are removing the non-numbers and then sorting the values, right? Simple. So this now is a sorted value. So now we are computing the length. So now n is the length of that all the assets that are there on that day, and we have their sorted values. Now you are taking the percentile to figure out how many assets we should buy and sell, and then we are picking the top five, top n, and selling the bottom n. We're not actually buying and selling here. We're just assigning to a variable that these are the things to buy, these are the things to sell, right? Based on the sorted array. So the generate signal has done its job. So it has gone through, analyze the factors. It has split the it is giving you what to buy and what to sell. Now the rebalance is being called. All it is doing is that for all the assets in our current positions, if we do not want to trade them in the current round, we are squaring them off so that we are starting from a fresh level. And then the ones that we want to go long, we are going long with this weight. And once we want to go short, we are going short with this negative of this weight. And the weight is 0.5 divided by the n. N is the number of assets we want to buy or sell, right? Why 0.5? Because we are doing buying and selling both. To keep the leverage at 1, we are doing 0.5. Otherwise, the leverage will become 2, the gross leverage, right? So this is very simple momentum strategy. Now, if you run it, so we'll see that the cross-sectional momentum, you can go back and run the time series one as well. You'll see that the cross-sectional and the time series has a very different signature. So it's not that when the cross-sectional works is the same time when the time series works, although both of them are capturing the same momentum underlying factor, that the past price will persist, the past trend will persist. But the way the works is very different. The reason is that the maths. Cross-sectional momentum works when in your entire universe of all the stocks in Nifty 50, you have a high amount of what we call autocovariance. Autocovariance means that if things are going up, it will keep on going up. So you need to have that. You also need to have a high variance among stocks. If all stocks go up and all stocks go down, it's not going to be very useful to you for cross momentum. Some should go up, some should go down. So there should be a high variance in that. And then there should be very low cross covariance, not auto covariance. That means if the scenario is that if stock X go up in the next period, stock Y also go up, that's a bad scenario for you. Because most probably you have already shorted stock Y, right? So you are basically long the autocovariance and long the variance of cross variance and long the your long the autocovariance, long the absolute variance of the mean returns, and short the cross variance, right? On the other case, in the time series momentum, we see that we are not market neutral. So the market direction will obviously be a very important part here. So in time series, you have an exposure to the cross autocovariance, as well as you have an exposure to the overall drift in the market. So if the market drift is high or the market drift is low, why high and low both? Because your sign can be both positive and negative. So this is what is called the mean square drift of the market. If it is high, then you will make more money. Yes. Yes. So percentile is just a, so for example, if I say I want to sell 5 percentile and I have only 100, that means I'll sell the top 5, buy the top 5 and sell the bottom 5. No, sell the bottom 5 and buy the top 5. So my total number of things to trade will be 10, right? Yes, even if it is going up in price, that is cross-sectional momentum. Example in the sense that this is a strategy. So you can, so we have just run an example that how its strategy looks like. Yeah, anything?